So let's take a look here at this. Okay, again, remember that tomorrow, okay, you're going to have 15 multiple choice questions and 3 free response questions, all right? Each one of the free response questions is basically going to correspond to one of our units that we've covered since benchmark 1, right? We've had 3 units since benchmark 1. We started with square roots and cube roots. Then we talked about rational functions, which is like polynomials divided by polynomials, right? That kind of thing. And then we also talked about exponentials and logarithmic functions, those 3. Okay? So this first one here, number 16, okay, talking about Jeremiah wants to take piano lessons at a nearby music store, charges $20 per 30-minute session. An insurance fee of $30 for the piano usage is also required. The fee lasts the whole time the student takes lessons. Okay, so it's like a one-time fee, in other words. So model the situation with a rational function. Okay, so this is very similar to our green one that we did, right, with Marlene buying a tie-dye kit for $50. She plans to buy T-shirts for $5 each, tie them and sell them. So blah blah blah. This one, it's having us find the average cost here. Okay, but again, average cost. So why don't you guys go ahead, just take like a minute here and just try 16A. Okay, so I'll leave 16A, the example from the tie-dye one, okay, from the green one up there. But go ahead and just take like a minute and just try 16A there, see what you can come up with. Okay, read the problem again if you need to. Okay, you're going to make C of S instead of C of T, but you're still doing an average cost. So go ahead and just take like a little bit here. Okay. Okay. See what you come up with there. I don't know how that's important. Question? I would, yeah, absolutely. Yeah, 2 parentheses, make it 1 4. Okay, so trying to do average cost here. Remember that average cost is the total cost divided by the number of items. Okay, so let's take a look, and that's equal to average cost there. Oh, thank you. Wow. Yes. I will take a donut. All right. Hey. All right. So, C of S equals. So, what kind of things are factoring into our cost here? What you know? What's going to affect our cost here for these piano lessons? What do we have to deal with? Okay, so So what are we getting charged here by, Mike? What are some of the charges we're going to have to face, or this Jeremiah's going to have to take care of? Okay, so 20 per 30-minute sessions. We'll do 20 S, right? Because we don't know how many sessions necessarily. So it'll be 20 times S. What else do we have to pay though for, Mike? Yep, and it's a one-time fee of just $30. So plus 30. So there's our total cost. But then we're going to divide that by what? Not by time in this case. S, the number of sessions. In this case, it's the number of sessions because that's what we're dealing with here is number of sessions. Okay. So number of sessions. Okay. So 20S plus 30 all over S. Okay. Folks, this letter A is super important because you need to know this in order to answer B correctly and in order to answer C correctly. So not getting A down is, problematic. Okay, if you miss A, then you really, kind of like hinder yourself from doing well on the other pieces. So it's super important that you understand how to get that down and then graph it. Okay. Will I still potentially give partial credit if you make some errors here, but you still graph, whatever, if you write this down incorrectly, but you graph it correctly, will I still give partial credit? Maybe we'll see here. But really, really try to make an effort to get that right because you're going to then graph it and you're going to answer questions based on it. So just keep that in mind. Super important. This is our answer, though. Any questions then on that? So
does the order of the 30 and the 20S go
Nah, 3 plus 2 is the same thing as 2 plus 3, right? So that's okay. Yep, yeah. If you have 30 plus 20s, that's fine. I'm guessing you guys kind of saw this one. You're like, yeah, let's do it this way. So yeah, that's okay. That's okay. All right, so let's go on to the next question here. So the next question, okay, graph the function on the coordinate plane below, label the axes. Again, folks, that means there's points attached, okay? Identify asymptotes with dashed lines, okay? So these are aspects you need to include in your graph. All right, now, what's the best thing we can use to help us graph this function? The calculator, right. So pull out the calculator. All right, I'm going to go to y equals, clear out my old stuff here. Okay, and is that how I type it in? Yes, thank you. You got to put parentheses. I typed it incorrectly, so that way you guys hopefully will see that mistake. Yes, numerator in parentheses. Denominator in parentheses too, technically, but since there's only one thing, you don't need to put it in parentheses. But it's not a bad idea just be in the habit of numerator in parentheses, denominator in parentheses. All right, let's go to graph this thing. Ooh, old viewing window there. Okay. And there's my graph. It's just like, that doesn't seem right necessarily. But again, go to your graph here and you will see the graph gives you an indication about what to use on your x and your y axis here. So I'm going to go to my window and change it to go from 0 to 55 and 0 to 55 again. Okay, and now we get a better picture of what's going on there. Okay, I'll go to my table. All right, start back at 0 there. Go to my table, and let's see, at 1, I'm at 50. So I'm just going to eyeball that. 1 is 50, something like that. Okay, and then I'll just jump ahead. 5 is 26. Okay, let's see here. 10 is 23. All right. I'm going to jump to 20. 20 is 21.5. Okay. I'll go to 30. 30 is 21. Okay. I'll go to 40 then. 40 is 20.75. I'll go to 50. And 50 is 20.6. So our graph looks something like this. Okay. I forgot to label our axes here, so let's go ahead and do that now too. Okay. So what is my x-axis going to be labeled by? What's like my x's here? Yep, but what's the label going to be? What do these numbers represent in our function here? The number of sessions. Number of sessions. Okay? And then what does our y-axis represent? The cost. But remember, it's not just cost, it's the what cost? This function is for the average cost. So this is the average cost. We'll say average cost, okay, which is going to be then dollars per lesson or session, you could say. Okay. So this is not the total cost, right? It's the average cost. It's the average cost. So, okay, and I just didn't want to fit it. I don't like writing it sideways. I wanted to write it upside like that, so that's why I wrote it there. Okay. Now, we're almost done with our graph. We graph the function. We label the axes, but we need to identify asymptotes. Okay. So, does it look like our graph has any asymptotes here? What do we say? Let's talk about vertical. Do we have any vertical asymptotes? At 0, we do. Yes, at 0, we do. Okay, right at 0, we do. Okay. So VA at x equals 0. Okay, or s equals 0 if you like. I guess I'll say s equals 0 since this is. How do you know Well, so you can kind of see how so one way you can look, well, actually, Tatum, how did you know it was at 0? What kind of indicated to you there? It doesn't go to 0. Yeah, you can look here and you can see the graph kind of curves up, right? And it's not going to, yeah, the graph, yeah. The graph kind of curves up here, Mike, right? So you can see that it's not going to go there. Also, if you go to your table, you'll see that at 0 you get an error, right? And then any other number is okay, but at 0 we get that error message. That indicates there's probably going to be an asymptote there too. You can also see in the function here as well that if I put 0 in for s, I'm going to be dividing by 0, which is undefined, and that indicates that asymptote there. Okay? Do we have a horizontal asymptote here? 20. At 20, yes, at 20, very good. Okay, and again, you can kind of see it flattening out here towards that 20 value. So yes, and again, using a dashed line because that's what we're told to do. Dashed lines there for the asymptotes. Okay, so HA at y equals 20. Okay. Now, Nick, what clued you in that we had a horizontal asymptote at 20? Did you just look at the graph and you kind of could tell? Yeah, kind of. Okay, what else did you use? Okay, what in the calculator did you look at to help determine? The table, yes. So another way you can look and tell if you have a horizontal asymptote is as you go farther and farther to the right, as we go farther on our x coordinates here, you can see that our y values are getting closer and closer to 20. Right? At 0, right, if I go back to 0 here, at 0 we start at 50, and then it jumps down to 35, then 30, and then 27.5. So we jump quicker, but then we start flattening out a little bit, right? We don't start decreasing as much. And again, the farther we go, okay, the closer we get to 20 there. As you can see, as I go, right, I'm down to 50. And if you really want to, check yourself, if you press second window and have your table start at like, I don't know, I'm just going to do one with a bunch of zeros there. Okay, this is like, well, anyway, it's really far, right? You can see like we're almost at 20 here, right, at this number. Okay, so you can see there that it's got to go to 20. Okay, so horizontal asymptote to 20. Okay, 2 points there. Okay, 2 points there. So please be careful there. All right, last piece. Determine the minimum number of lessons that brings the average cost below $24. Okay, determine the minimum number of lessons that brings the average cost below $24. So, how can we do this one? What could we do here? Determine the minimum number of lessons that brings the average cost below $24. Ideas? So, yeah, Patrick? Put what in, sorry? So, well, we're not going to put in 8 for x. We want their average cost to be 24 here. So what we put in instead? 24. But 24 is not a number of sessions. 24 is the average cost. We're going to do 24 equals 20s plus 30 over s, like that. Okay? So that 24 goes right here. All right? So, now, once we have it set up like that equation, what options do we have to solve that equation? We could what? What's that? Not plug in 24. Remember, we're setting it equal to 24. 24 is not a number of sessions, so it does not go in for s. We set it equal to it because that's where our average cost is. How can we solve this equation? What's some options do we have? What's that? Yeah, so we could solve it algebraically. I'm going to get to that in 1 second here. We also could use our graphing calculators, right? Like just graph that 24, okay, in your y2. So I'll graph the left-hand side in y2 in this case, and the right-hand side in y1. I'll just graph it and see, look, there's the point of intersection right there. So second trace, intersect, and I'm just going to go close to the point of intersection. And then hit enter, enter, enter. And there you go. At 7.5, and so that, of course, then will be how many sessions, because you can't do half of a session probably, right? So how many sessions will it take to bring the average cost below $24? 8, right. Another way to look at this, go to your table and just watch your y values here. Okay, they're at 7 sessions. The average cost is $24.286, right? After 8 sessions, the cost is now below $24. So it would take 8 or more sessions to do that. Okay, so the answer is 8 or more sessions. Okay, but we can also solve this algebraically. So I'll show you that here real quick. We're going to multiply both sides by s. To get the s out of the denominator there, we'll have 24s equals 20s plus 30. Okay, we have s's on both sides, so I'm going to move this 20s over here by subtracting 20s on both sides. And so 24s take away 20s is now 4s, which is equal to 30. Okay, and so then divide both sides by 4. And s, there's your 7.5 that we found. Okay, but again, our answer is not going to be 7.5 because we probably can't do half of a session. I mean, it depends, but more likely we'll say 8, right? We need 8 or more sessions then, which is what that rounds up to.
So you have to show your work at the end of the graph?
No, you don't have to. You can solve it graphically, okay? And it says graphically above, but I'm okay with you just using your graphic calculator, that's fine. Or show your algebraic work here below. So your choice, Mike, about how you choose to solve it. If you use your calculator, that's fine. You can just give me the answer there. Okay, but there are 2 points associated with that, so do be careful. If you show no work down here, you just give me an answer, please make sure it's the right one, or else it's going to be hard for me to give you partial credit if you don't show any work. Okay? Questions on that one? All right, so this one was almost identical to the one on the green paper, right? We had the average cost. We had the graph with a horizontal and vertical asymptote. Average cost was on the y. Number of shirts in this case was on the x. And then we also determined the minimum number of t-shirts that brings the average cost below $8 in this case. So here it was below $24. Here it was below $8. So, I mean, with this information, we're pretty sure we're going to have a question just like this on our actual benchmark, right? So, all right. Turn the page here. We'll go to the next one. Okay, so here we've got our square root function, all right, which is very similar. Even the function is very similar here to the green paper one, right? Here it was t equals 0.6 times the square root of L. Here for the blue one, it's s equals square root of 30d. Now notice in this one, the 0.6 is outside the square root, but here the 30 and the d are both in the square root there. Okay. So the formula to estimate the speed a car is traveling before an accident is s equals the square root of 30d, where s is the speed in miles per hour and d is the distance in feet the car will skid before stopping. So that is something that I want to inform you guys about, right? I don't know if you know this or not, but there are formulas that people can use to determine how fast you were going before you got into an accident. Meaning that if you tell your insurance company that, well, I was going the speed limit and I just ran into this person, well, they will be able to calculate whether you're actually going the speed limit or not before you get into an accident. So just keep that in mind, all right? If you ever get into an accident and you are talking with people that are in authority, there are calculations that they can use to figure out how fast you were going. So anyway, I'm not sure if this is the exact formula, but this is what we're using here in our case. Okay. S is the speed in miles per hour, and D is the distance in feet the car will skid before stopping. Okay, so we're going to graph here. All right, and of course, when we go to graph something, we're going to use what? Graphing calculator, right? So we'll put it into our y equals here. So square root of 30, and we're going to use x instead of the d there. Okay, 30x, and we will again take a look at your grid here. We've got from 0 to 180 and 0 to 90. So I'm going to adjust my x min to 0 still, and the x max will be 180. And then y min will be 0, and y max will be 90. Okay, and then we'll graph.
What's the use for square root of 30 in there?
Square root of 30d. Don't forget there's the variable in there too. You want to use that. The x. Use x, yeah. Mm-hmm. Yep, and there's our equation. And again, I'll go to my table here. Okay, at 0, we're at 0. Okay, and then I'll jump to, goodness, 20. Okay, so I get about 25 for 20. So just a shade under 25. Okay, I'm just gonna, let's see here. I'll go to 60 next, just because I don't want to spend all day plotting points. So 42.4 for 60. Okay, And if you want to know how to like jump without having to scroll, okay, because it's a lot to scroll from like 60 to 70 to 80, if you press second window, that takes you to your table setup, you can tell your graphing calculator where your table is going to start. So I'm going to have it start at 80, and then go to my, and then see at 80, it's 48.99. Okay, and then I'll jump to 120 here. So 120, I'm at 60. That's a nice easy one. 120 is 60. Okay, I'll go to 160 then. 160 is almost 70 there. Okay, and that's good enough for me. That's good enough number point, I think. Just kind of connect the dots. Okay, like that. Okay. What's the label for my x-axis going to be? That is a number of, well, what does this number represent here? The D, right, which stands for distance in feet. So this is the distance the car skids in feet. Okay. What about the y-axis here? The speed of the car, okay, miles per hour before the accident occurred, before the collision occurred. Okay. But yeah, after accidents, you can see people measuring how far. You can find people measuring like the lengths of the skid on like the road and stuff like that. So, assuming you brake. I guess if you don't brake, then they won't know that. But most people try to brake before they get into an accident. Okay. So, how fast were they going if the skid distance was 120 feet? Well, actually, this one's really nice. That was the one that worked out nicely, wasn't it? So, 120 feet, speed was 60 miles per hour. Okay? So, 60 miles per hour. Okay? Label your answer means to give units to it and stuff like that. Okay? What else could we have done here? We could have done square root of 30 times 120, right? The square root of 30 times 120, right? Just plug 120 in for the distance there, for D. Okay? You could also go to your table and go to 120 on your table there, and that's where it's 60. Okay? Or it says 60 there. So either way, your answer is 60 miles per hour. Okay? How far did the car skid if it was traveling 30 miles per hour? Label your answer. Okay, so where would this go in? For which variable? If we're traveling 30 miles per hour, which variable should it go into here in my equation? In for what? In for what? S, the speed, right? It's a speed. So we'll put 30 equals the square root of 30 times D. Okay, now to solve this one, well, we have a couple options. Option one, we could graph 30. Okay, go to my graph and see there's my point of intersection. Second trace, intersect. Okay, go close to that point of intersection there. Enter, enter, enter. 30, it's 30. Okay, well that's kind of nice. So distance equals 30 feet. We would expect to skid. Seems rather far for 30 miles per hour, so I feel like this equation can't be quite right. But anyway, we could also solve this algebraically here, right? What would we do if we want to solve algebraically? What would we do here to get the variable D by itself here? What would we do first here? How do you cancel out a square root? Square both sides. Okay, so 30 squared is 900, and then square the square root, you get 30 times D. And then what's the final step here? Divide both sides by what? 30, yeah, divide both sides by 30. Get the letter D by itself, or get the variable by itself. 900 divided by 30 is, well, it's 30 again. So there's your...
But 900 is square root.
To get rid of the square root here, Mike, we squared both sides. And that left us with 30 squared is 900, and then we divided both sides by 30, because it was 30 times D, so we divide both sides by 30. So 900 divided by 30 gives you the 30 feet there. Okay? But of course, if you guys get stuck tomorrow on the benchmark, right, then we can always graph the left-hand side, graph the right-hand side, and find the point of intersection there. And 30 feet would be your answer. Okay? All right, last question here. What's the average rate of change? And of course, when we see average rate of change, that means we're finding the slope. Okay, which is y2 minus y1 over x2 minus x1. Okay, now we're told two distances, 130 feet and 135 feet. So that gives us x coordinates. We got to find their matching y coordinates. Okay, I'm just going to go to my table to do that, I think. But you could also plug them into your function. Plug 130 in for d, plug 135 in for d. Okay, so for 130, I get 62 point, I think that's supposed to be just 0.45. I think that's a rounding error on the calculator's part, so 62.45. Okay, and then 135, I get 63 point, we'll say 64. Okay, and then we'll just subtract the y coordinates. So I'll do the second one, 63.64 minus 62.45, all over 135 minus 130. Okay. Question?
You got that by looking at the graph and seeing where it was at 130 and 135?
Yep, exactly right. Just finding the matching y coordinates for those two things. Exactly right. Okay.
And what makes it, how do you know which one is X and which one is?
Okay, good question. So this, what's the label for the 130? It's in feet. Okay. If you go up to your x-axis here, Mike, right? The x-axis, the x values, right? Those are distances in feet. So okay, that matches, right? 130 feet, that would be a distance, so it has to be an x value. If you try to match it to the y values, Mike, you're going to be trying to get a miles per hour. Remember, our y values are a speed. Well, that's not a speed, right? It's just a distance. So you can use your labels there to help you with that. Okay? But there's the average rate of change there. Okay? Question, any other questions there on number 17? Okay? So again, 17, very similar to 17 on the green, right? There's our square root thing. There we plugged 36 into the function and we got an answer. Then the letter C, we set the function equal to 3 and we solved, okay? And then letter D, what's the average rate of change? Okay, so again, almost identical kind of problem there to the green one. So pretty good chance we'll have a question just like that on the actual benchmark, right? Even with all these little pieces, right? So no surprises, hopefully, right? Should just be like that. Okay. All right, the last one here, number 18. A virus has been contracted by two individuals. The virus is growing at a rate of 28%. Where P of T is the number of people who have contracted the virus over T days.
Wait, can you go back to this one?
Oh, go back to the other one? Yeah, sure.
Yeah, to the bottom.
Yep.
And if it's like that, so you can just slide to one number?
You can put it to one number if you want to. I'm okay. So I circled both there because I think both are okay. If you put 1.19 over 5, that's fine. Or if you put 0.238, that's fine too. Either one's okay. Okay. Good now? Good? Okay. All right. Last one here. A virus, like I said, contracted by two individuals. The virus is growing at a rate of 28%, where P of T is the number of people who have contracted the virus over T days. A vaccine is introduced into the population and can be modeled by the equation G of T equals 79 e to the negative 0.07 T minus 2, where G of T is the number of people that still have the virus after the vaccine was introduced, and T is time in days. So this one's a little bit different, but let's just see here. So 18A, write a model that represents the spread of the virus P of T. Okay, so we're talking about growing, right? And so what kind of equation are we going to use here to model the spread or represent the spread of the virus? So, Mike? Exactly right. Y equals A times B dx. This is the exponential growth / decay. Okay, y equals a times b to the x. Okay, so we're going to use P of T though because that's what they asked us to use here. So we'll say P of T equals Okay, what is our A value going to be here? What's our A? Remember, what does A represent? A is the starting amount. How many people started with the virus? 2. Okay, that's our A value right there. 2. Okay. And then is this going to be an exponential growth or exponential decay? Growth, right? We're growing at a rate. So since it's growth, we're going to have our B value equal to 1 plus R. Okay? Remember, R is the percent as a decimal there. What is our percent growth rate here? So yeah, so 28% is the percent growth rate. So it'll be 1 plus 0.28, which is, 1.28 then. And so we'll do 1.28. And then don't forget the to the t. Right? Don't forget that t there. A lot of people on that last exponential test came up to me with questions. Mr. Witt, I'm graphing a flat line. That's because you forgot to put the t in for your exponent there.
Wait, so you just moved it up, okay.
Yep. T is the exponent. And so there's the model that represents the spread of the virus.
Why is it 1.28?
So why is it 1.28? Because when we it has to do with something like this. Like if you're only we're told, right, that the growth rate is 0.28, right? But what we're going to do here is we keep multiplying by that growth rate. If you start with 2 people and you multiply by 0.28, right, 2 times 0.28, you're now down to 0.56 people.
Yeah.
So I'm saying you're not growing. This is how much it's changing by. So you want to add that 0.28 on to the original amount. This is like when you go to pay, like the best way I can compare this to is like when you go to pay for something at the cash register, right? You know that when you go to buy something, you see the price tag, okay, $5.99 or something like that. You go up to the cash register, you're not going to pay $5.99 unless it's like, I think, certain food, like food, for example, they don't tax. But like if it's like a piece of clothing or something like that. $5.99, right? You go to the cash register, they charge you, they're going to charge you $6.35 because they're adding on tax, right?
Yeah.
So tax is 6%. So if I take that $5.99, okay, and I multiply by 0.06, that is not what you pay, that's the tax. We want to add that on. Well, the way you can do that is by doing 5.99 times 1.06. The 1 means you'll keep the original price, and then the times 0.06 means then you'll add on that additional amount. And there you can see, $5.99 plus 0.3594 will be $6.3494.
So you do that if you're adding.
Yes, if you're growing, you add 0.28 to 1. Okay, if it's decaying, Mike, if it's shrinking, right, you'll do 1 minus 0.28 is what you get there too. Okay, so anyway. All right, letter B. During which day are the 2 populations equal? Well, so we're setting this population equal to, what's the other population that we're talking about here? The vaccine, right here. So the 79e to the negative 0.07t minus 2. Okay, so this is P of t equal to G of t here. You want to know during which day. So we're finding the time. Okay, now to solve this, we are not going to do the algebra here, okay? Easiest way to solve this, graph the left-hand side, graph the right-hand side, find that point of intersection, okay? So let's do that here. 2 parentheses 1.28 to the x, and then 79e to the negative 0.07x, and then minus 2. Make sure you come out of the exponent there to put that minus 2, okay? The negative 0.07x and the minus 2 is outside the exponent, so make sure that you move that. Okay?
Wait, what is that? Oh, that came from the...
Okay? So make sure you move that exponent out there. Does anyone need a calculator, by the way? I should have asked this earlier, I guess.
Yeah.
Mike, do you want one to borrow? Here. Anyone else need a calculator to borrow? Okay. Make sure you type it in correctly, right? That's super important. You guys can type that in correctly. Okay. If you have the old school calculator, or if you have the older kind of calculator, let me adjust that here. So please be careful how you type it in. Oh, hello, CJ. Oh, there she is. Hello. All right. And then like the other, sorry. So if you have the older kind of calculator, please be careful here. There's two ways to type in E. And I think I talked with you about this to you yesterday, but I'll say it again. There's two ways to type in E. There's E above the division symbol, but there's also E to the X above the natural log button. I'd really encourage you to use the natural log button one and not the division symbol one. Okay? But just make sure that if you're going to take E and raise it to a power, that you put parentheses around that exponent, because here, for example, right, you have a negative 0.07 and a t. So it's a good idea to use parentheses there, okay, to make sure you type it in correctly.
Are we raising x to a power?
No, it's to the power of x. X is the exponent. Hello? Can do? Okay, it's not a problem. Bye. Andrew, Miss Piles wants to see you in the AP office. Okay, so anyway, Michael, you're good. Questions answered? Okay, so now we'll graph. And aha, there's my point of intersection. Let me see if I can see it in my normal. Let me try zoom 6 here and see if I can see it where my normal viewing window there. There's that. Okay, so you can't see it in the normal viewing window, so we'll have to adjust our Y max. Let me just adjust it to like 50, so that way we can just kind of see there. So we definitely need to be able to find that point of intersection. Oh my, okay, so I need to go over to the right more, so I'm going to adjust my X max sum, and I'll make that 30. Let's see if that works there. Okay, so there's the virus population. There's the vaccine population. All right, so second trace, intersect. So 11.4 as our intersection point. So during which day are the two populations equal? During day what? 11. Yeah, during day 11. Okay, it's going to happen during day 11 when they are equal, right? Because it's 11 and then 0.4. Okay, so during day 11 is when it will happen. Okay. All right. Last one here, letter D or letter C. After 15 days, what is the difference? Difference means what operation? Subtraction. After 15 days, what is the difference or subtraction, right, we're going to do here, between the number of people that would have the virus if not vaccinated? So that's going to be our P of T. So we'll do P of 15 minus, and the number of people who still have the virus after the vaccination was introduced. Round to the nearest person, show your work, or justify your answer here. Okay. So P of 15 is the number of people that have the virus if not vaccinated. Okay. And then we'll subtract G of 15, which is the number of people who still have the virus after the vaccination was introduced. So G of 15 is the number of people who still have the virus after it's introduced. So basically we're just going to find P of 15 and then subtract G of 15, and that's it. Okay, so hello, Lauren. Come to deliver some text of your books. Okay, very good. Thank you. Okay. Yes, ma'am. Why? Do you want this little strip here? Fresh. Okay. So P of 15, I'll go to my graphing calculator here. Okay, at 15, P of t is 81.13. Okay, and then 25.65, I'll say, for g of 15. And again, I'm just using my calculator here. You could also just plug them into the functions themselves, right? Your P of t here that you found, and your g of t here that you found. Okay, but that's what you're going to get. And then when we do that subtraction, we get 55.48. I use the table just because I already had, so I had typed in P of t and G of t right there into my Y1 and Y2. So when I went to my table, I just found when the day was 15, okay, after day 15, and then that would be my P of t at 15, and that would be my G of t at 15. Yeah. And so I just get those. But again, you can get these by plugging into the function too and getting them that way. So it says round to the nearest person, so I'm going to say, this is actually kind of close, because you could round the 8 up to 0.5, which would round up to... So I'm going to say 55 or 56 here is okay. Okay? So we're talking about that whole person there. Okay?
And if it doesn't say slope, you should do that.
Say one more time.
Remember, other one did slope and this one did.
Correct, because this one did not ask for the average rate of change, right? So no slope stuff. Only when you see average rate of change, Michael, do you do that slope stuff. Okie dokie. All right. Whew. So I'll go ahead and give you guys like 20 or so minutes to work on some of these multiple choice questions. All right, and then we will pause and go over anything. All right. I did record this, so I will be posting it to the Google Classroom.